All right, great job with the notes. 3-1. 3-1, 3-2 are not too bad. And then 3-3 is really starts to get crazy. So, and the 3-1, 3-2 are just a little overview of what's going on. And then the next couple sections get a little intense. Okay. Um, so remember we have our hand in assignment Friday that I'll give you Thursday at the end of the answer session. Okay. So differentiability. Okay. So what would happen is how might the derivative fail to exist? Okay. So here we already have function will not have, okay, this is where it will not have a derivative, at the point where the slopes of the secant lines fail to approach a limit as x approaches a. So it could happen that they fail, but we saw this in chapter 2 with our discontinuity, with our limits approaching one negative infinity, one positive infinity. Okay, here we're going to try to recognize them just for graphically in our head. So some of you don't have your calculator, so I can't get too in depth with the graphing. Okay. Now, anytime you have an absolute value just by itself, an absolute value, it's a corner. Okay. So it has to be a smooth curve. Okay. Smooth, unbroken curve. Okay. That's all differentiable. Okay. Once I come to a corner, I can't differentiate it. Okay. They fail to exist. So that's at x equals 0, you have a corner. Okay. So the derivatives will be different as I come from the left and from the right. Okay. A cusp. Okay. What's a cusp? All right. So a cusp is something like this. Okay. Kind of like an absolute value. I don't know if you can see this. Okay. There it is right there. Okay. So at 0, we have our cusp. And that occurs when you have an even power over an odd power. That's when that occurs. That's when you have a cusp. Okay. And it cannot differentiate. Okay. The next one is a vertical tangent. So with the vertical tangent, okay, what happens here is if I rewrite this, okay, as a cube root of x, I write it as x to the 1/3. If I have an odd over an odd power, I'm going to end up with a vertical tangent. Okay. The other one, okay, the other one was even over an odd. Okay, and that gives you a cusp. All right, so odd over odd gives you the vertical tangent. Okay, so anything over an odd is not going to work. Okay. Now you also have discontinuity. Okay, will cause both one-side derivatives to be non-existent. Okay, so here's our discontinuity. All right, so remember this was the jump discontinuity. All right, because at 0 again, it's going from down at the bottom. I don't know if you can see my cursor going from down here to up over here. Okay, that's a jump. Okay, remember we have this removable. Okay, now here's let me put this up. All right, this is kind of short and sweet for now. Okay, so all points in the domain where it is not differentiable. All right, so here's your absolute value. So you know it's going to be a v. All right, but you should be able to know where that point that it's not going to be differentiable is. And remember, inside the absolute value moves the x-axis and it moves the opposite. Outside moves the y. So it goes to 3-2. Okay? And I think that's what I have underneath here. Yep. So at, I don't know what this is here. Okay? So at x equals 3, okay, that's where it's going to be not differentiable, and the coordinate's going to be 3-2. Okay? So I'd accept either answer. Okay? All right. So let's see what else I want to show you here. We're not doing the derivative on the calculator. Okay, we don't do that. We do them all straight out. Be careful. Differential implies continuity. Yeah, if it's differentiable, then it's continuous. Hopefully you guys got your books. This is on page 109. Okay, where these are in more detail. Like I said, we try not to use the calculator. And that's it. That's about it for this section. Okay, so it's quick. Okay. Some things I told you, some things I skipped. just because of trying to squeeze in everything I can in this time that I have. Okay, so here we are. I covered it up. All right. Some of you already saw it, which is okay. Now, this one here, we're not going to be able to put in the calculator, so we're going to talk more about these up here. Okay, the trig derivatives. We're going to talk a lot more about those. Okay, what the graphs look like. Okay, but that's discontinuous at x equals 0. All right, because it doesn't reach 1. Okay, it doesn't reach 1. Remember your tan graph? Okay, but the inverse, okay, it doesn't work. Okay, here we have vertical tangent. Why is it a vertical tangent? Because this turns to an odd over an odd. Okay, so that has your vertical tangent. Discontinuous for A, B, vertical tangent. All right, now C and D are both cusps. All right, D is easy to see. You have an even over an odd. It's a cusp. Now, why is this, okay, a cusp? Because if I have the absolute value of x, it's also known as x squared, okay, or similar to an x squared, meaning that it's always going to be positive. Okay, so we've used this as x to the 2/3, which is a cusp. Okay, that's how we view that one. Okay, and then like I said, here are some tricks to remember. Okay, vertical tangent, x to the odd over odd. Cusp is x to the even over odd. And then a corner is your absolute value. Okay. And I think, let me see, I think that's about it. Like I said, short and sweet. Okay. Yeah, I don't know what the heck that is. Okay, so, okay, homework. All right. Little review. On page 106, number 19. 106, number 19. That's the lines that tangent and normal to the curve at the point. Okay, so it's going back to chapter 2 and then also finding the derivative. So remember, you have to find the derivative. And I want you to do this x cubed, okay, remember with your x minus, or x plus h, f of x plus h minus f of x all over h, okay? And then find where the slope is, plug it in, find the tangent and normal, okay? And then on this page here, page 114, I hope you can see it. Like I said, if you can't see it, you guys got to get your books, okay? We're doing page 114, number 5 through 10, okay? Identifying if it's differentiable, continuous but not differentiable, neither continuous nor differentiable, okay? Looking for your corners, your cusps, your discontinuity, okay? And identifying those, okay? And let me see if I can get all the answers for you so you can see them right there. There you go. Okay, so take a picture of it, whatever you need to do, pause it, try it, whatever. Okay, so 5 through 10, those graphs. Okay, all right, and then we'll get into some rules next week, and then I'll talk. Like I said, Thursday I'll have the answers, talk about them, and then whatever you need, and then I'll give the handed assignment, which will be due Friday. Okay, we'll see you.